We saw the future of human spaceflight in action early on November 18th, and it was amazing. This is the second Starship flight test. The best chance humanity has for a future among the stars rose with the sun over the Gulf of Mexico. For the second time, the most potent aircraft ever built achieved flight and fulfilled all of our expectations. And a little bit extra. It's critical to keep in mind that this second flight's primary objectives were to test the new hot staging technology and get the vehicle through stage separation. Anything more than that would be a welcome perk. SpaceX crews worked through the night to destack the Starship and replace 3 of the electric motors that control the rotation of the Super Heavy booster's grid fins after a Friday launch was scrubbed due to a faulty grid fin actuator. One of the motors was confirmed to be broken, but 2 more were replaced out of caution. After that, the car was repacked and ready for takeoff. The Starbase launch pad's ground systems were working non-stop at the crack of dawn to be ready for the booster's propellant loading. In contrast to the scheduled launch time of 7 a.m., this started at T-1 hour and 37 minutes. Everything was proceeding as planned and without hiccups. And up until T-40 seconds into the pre-flight checklist, that pattern persisted without deviation. This is a scheduled hold for the launch of Starship. At this stage, crews have the option to stop the countdown so they have more time to do final checks. Up to 30 minutes can pass while the ship is held at 40 seconds. Starship is freed from the hold-down clamps on the launch mount, fully fueled, and running on its own internal power at the time of the hold. The countdown resumed and launch is scheduled after the upper stage's final pressurization was verified. Water is shown spewing out of the new flame diverter system at T5 seconds. Then, as the engines rapidly build up thrust, we see the first plume of flames coming from the Raptor engines right before the clock strikes 0. Before we witness the ship's first movement, all 33 engines are operating for almost 5 seconds. From this point on, things pick up speed. The rocket is already moving at 140 kilometers per hour when the booster's tail clears the top of the launch tower by T+10 seconds. Since the first Starship flight test back in April, SpaceX has made numerous upgrades to the spacecraft and the launch pad, which are visible from the moment of liftoff. The most noticeable distinction is that the rocket can be seen as it lifts off the pad. A massive cloud of rock, dust, smoke, and debris blanketed the first launch. Flight 2 did not experience this again. This time, I've looked from a few various camera angles, and I don't see any noteworthy debris ejecting from the launch pad. There is definitely a lot of loose material that flew from the shockwave. Everything that wasn't secured with bolts at the launch site most likely went airborne. However, nothing resembles the previous ejection of ground that I can see. Thus, first findings suggest that the showerhead performed as planned. Now that we're looking back at the Starship, this is how a rocket that burns methane should seem. A flawlessly smooth, even, and clean fire plume that descended directly from the extremely massive booster. The smoking and sputtering of flames that occurred on flight number 1 is not visible to us. This is the first time that all 33 engines are operating flawlessly, for the record. SpaceX never manages to get all 33 booster engines to operate for the full test duration, not even during ground testing. Up to maximum Q, the Starship ascends in a straight and smooth path that represents the area where the rocket's body is under the most mechanical stress. This occurs at a speed of 300 kilometers per hour at an altitude of 10 kilometers above sea level, approximately at T+1 minute and 5 seconds. The major event, stage separation, comes 90 seconds later, the furthest distance a spacecraft has ever traveled. There is no main engine shutdown, or MECO as we know it, because we are hot staging. Rather, the majority of the engines cut off, leaving the 3 Raptors in the middle of the rocket to continue defying gravity as the ship gets ready for action. The Starship is currently 69 kilometers above Earth and traveling at a speed of 56 kilometers per hour. A lot of things are going to happen quickly now. The ship's 6 engines fire, the clamps holding the rocket's 2 stages are released, and the hot staging procedure starts. The remaining 3 booster engines will start to rotate the booster 180 degrees as the ship moves away, pointing the top straight back down towards the Earth using their gimbal systems. The side vents of the hot stage ring on the booster are where we can observe all of the flame and exhaust from the ship engines being deflected out during the hot stage. In order to avoid firing straight into the booster's top dome, the ship's 3 center engines are used their gimbals to slant as far outward as possible. And this is where the initial issues appear. We may observe that the initial engine restart has already begun when the booster begins to flip. Though some of the 13 interruptors are still clearly dark, the majority have relit. Telemetry indicates that 4 engines are out as the booster approaches, with only 2 of the center group and 3 of the outer ring engines remaining operational. As a result of their concentration on one side, there is an unbalanced thrust now. Upon finishing the flip, the booster's airspeed has decreased to around 4,700 kilometers per hour. Consequently, it loses about 1 kilometers per hour during the flip maneuver. As we can see, one of the 3 failed booster engines is now out of commission. This could be a deliberate attempt to even out the thrust, or it could just be another mistake. There is some sort of occurrence at T+3 minutes 15 seconds, where many engines fail all at once, increasing the total number of Raptors that have failed to 7. As of right now, only 4 of the mid-ring engines remain operational. Additionally, they are all grouped together, creating a very asymmetrical push. Of the core group, 2 are still active. All of the booster engines are out by T+3 minutes and 18 seconds. The booster itself detonates at +3 minutes and 20 seconds. This occurs quickly, at 90 kilometers above sea level and 3,800 kilometers per hour. It essentially bursts like a balloon. This is the flight termination mechanism removing the booster from the air since the engine problems have caused it to veer significantly off course. In this case, this is just what it should do. Therefore, the self-destruct feature of Flight Number 1 was yet another enormous advance. What then became to the booster? The hot staging event does not appear to have caused any damage to it. It seems more likely, in my opinion, that there was a problem with tank pressure during the flip and that fuel sloshed around. The fluid dynamics are completely unknown because no one has ever attempted to turn such a massive fuel tank around in midair, but SpaceX now has a lot more information than they did previously. Throughout the entire duration, however, the ship stage has been actively moving forward, accelerating and increasing in height as it approaches little less than orbit. The goal of this flight test is to bring the ship extremely near to orbital velocity while maintaining a speed at which a deorbit burn is not necessary for it to fall back down. The ship will still strike the environment with enough force to put the heat shield tiles to the test at this speed, should it progress that far. We're hearing calls from the ground crew stating that all systems are operating as intended even though the ship is still using all 6 engines. We can see some intriguing white spots on camera at T+4 minutes. These could be either UFOs or booster debris that is catching the sun. We hear the call out for ship trajectory, nominal, at 5 minutes past T. We hear ship pressure, nominal, at 6 minutes. So far, everything seems to be moving along quite nicely up there. The ship is moving at 17 kilometers per hour and is 149 kilometers above sea level until we reach T+7 minutes 7 seconds. We can also see a jet of smoke on camera. The ship's second plume appears at T+7 minutes 40 seconds. It is traveling at 21 kilometers per hour, and the telemetry indicates that all 6 engines are still running. The altitude stays at roughly 148 kilometers. The plume clears in 7 minutes and 50 seconds, but the ship's engines are only barely visible to us. Telemetry indicates that the Starship's engines were all turned down at 8 minutes, 3 seconds. The speed of the car is little over 24 kilometers per hour. The conclusion of Ship 25 is then signaled by a little puff that appears 2 seconds later, which is soon followed by a larger puff. Very late in the second stage burn, flight termination began. The second engine cutoff, which would have initiated the ship's coasting phase, was just a few seconds away, all the way to the Pacific Ocean and back again. Thus, the success rate of what we observed here was probably around 80%. Actually, we were only deprived of 3 major occasions. First, the booster was brought back so there was no landing burn over the lake or re-entry burn. Second, while this is not a major issue, there was no second engine shut off on the ship. Thirdly, it is unfortunate that we were unable to see the upper stage's re-entry as it remains a significant unknown. That kind of large-scale return from space has never been attempted before, and we still don't know how well Starship's heat shield tiles will hold up under pressure. A number of the tiles fell off during launch, primarily along the weld lines, as you can already see from some still shots. As a result, it's likely that the ship would have broken apart regardless, but we won't know for sure until we can reach that point in the flight. Bill Nelson, the administrator of NASA, appeared rather pleased with the outcome. Shortly after the launch, he posted on X, expressing his congratulations to the crews that performed well on today's flight test. Spaceflight is an audacious endeavor requiring a fearless inventiveness and a can-do attitude. The test of today is a chance to grow and then take off again. NASA and SpaceX will work together to bring people back to the Moon, Mars, and other planets. And that's arguably the most crucial thing to keep in mind. Right now, we are making the initial, very little steps toward the greatest jump humanity will ever make in our lifetime, putting humans to live first on the Moon, then on Mars. There will be many setbacks along the way, and this won't be simple. Regarding SpaceX's future plans, it's likely that another FAA mishap investigation involving the Super Heavy rocket will be underway. It performed better than we had anticipated, but it did have a problem and go off track, so that needs to be investigated. However, this will be a far less involved task than the 420 launch investigation, more of a normal one. In theory, SpaceX is still permitted to launch 5 times from Starbase in 2023. Will they attempt to capitalize on a December debut window? Then, we know that the launch pad was not destroyed, but it might still sustain damage, or, at the absolute least, SpaceX may have found something that could be improved. This all depends on the state of the ground systems. It is likely that SpaceX will wish to modify the orbital tank farm at the launch site before attempting another launch, since we are aware of their plans to do so in order to facilitate faster propellant loading. Additionally, there are growing signs that SpaceX is preparing to build a second launch tower at Starbase, so it's possible that for a short moment, their focus is drawn to that project. In any case, there won't be any more Starship launches for a few months. A decent estimate for late winter or early spring of 2024 would be appropriate. Regarding what the next Starship mission would entail, well, they already have Ship 28 and Booster 10 nearly ready to travel, so the hardware is unquestionably not in doubt. Do they aim for a complete orbit in terms of the flight profile? Do they try to deploy a payload? It's highly in my opinion, that SpaceX will attempt the exact same flight profile as they did on November 18. For we still require that information regarding the upper stage, and it ought to be known prior to it reaching orbital velocity or attempting to launch anything into space. This is Cosmic Era as usual. Please consider giving this video a thumbs up and subscribing to our channel in order to see more videos similar to this one. Until the next time.